In this video, I just wanted to share a quick tip relating to the two different equations that you have for hyperbolas. These two equations, even though they look very similar, actually create a very big difference in the graphs of your hyperbola. This first equation here is for a hyperbola with a horizontal transverse axis. A transverse axis, you recall, is a line segment between the two vertices. So if your transverse axis is horizontal, then your hyperbola would look kind of like this. And if your transverse axis was vertical, then your hyperbola would look like this. And students have a hard time remembering which is which because these equations look so similar. And so let me see if I can share just a quick little tip with you. All right, let's look at a particular example. This one has a horizontal transverse axis. You see the foci here, and you see the two vertices here and here. And just to make it easy, I just centered it at the origin, so the h and the k are 0. That's why you don't see them here. And I just want to give you a tip for how to associate this guy with this equation as opposed to the other equation. And so here we go. For somebody like this, think about letting x or y be the same as the x or y coordinate for the center. For example, let's let the x be 0. So if you let x be 0, what you're looking for when you set x to be 0 in the equation is a y value that goes with this x that's on your hyperbola. So hopefully what you'll get is some point to go with this x. So you have 0, 1 or 0, 5 or 0, 7 or something like that that's on your hyperbola. So if x is 0, then what happens is this term goes away, and then you have minus y squared over b squared equals 1. So this is a minus. But think about y squared over b squared. Y squared over b squared has to be positive. Now, is there any way for a negative 1 times a positive number to give you positive 1? No, that's impossible. And that gets reflected in the graph. You see along the y-axis, this is completely empty. There are no y values for x being 0. And so we can use that to our advantage. So when you see something like this in general, like x minus h squared over a squared minus y minus k squared over b squared equals 1, think about this. You can't have a y coordinate when x is at h, because if x is at the center, then, and this term is 0, you get an impossible situation. Negative blank equals 1. That can't happen. So what that tells you is that this guy's going to fan open left and right. And then on the contrary, look down here at this equation. If you let y be k, right, for this leading term here, and this term goes away, then there is no x value such that negative blank equals 1. And so you get this empty space right here. So you can tell immediately, you can tell right away whether this guy's going to fan away to the left and right or up and down without straight memorization of horizontal transverse axes and vertical transverse axes. That's just too much to remember, and in fact it's very difficult. So let's close with just a made-up example. I'm just going to make this one up on the fly. Let's say we had x plus 2 squared over 16 minus y minus 5 squared over 9 equals 1. I completely just made that up off the cuff. I don't want to graph it. I don't want to find any information about it. My question to you is simply this. Does it open left and right, or does it open up or down? Because that's really half the battle, is just knowing which it is. So using the tip I just gave you, if x was at negative 2, right, if x was at its center value and this term went away, then the y coordinate, there is no y coordinate such that negative blank equals 1. So which of these has a possible blank for a y coordinate? Well, it looks like this guy. So this would be your answer. And if we cheat a little bit, if we look back here, sure enough, this was the horizontal transverse axis that did in fact open left to right.